there is an alternative way of getting these relations also. Suppose there is a particle m1 here, there is a particle m1 and another particle m2 is here. m1 has radius vector r1, m2 has radius vector r2. m1 has radius vector r1, m2 has radius vector r2. Let the radius vector of center of mass be, let this be the center of mass. Let the radius vector of this center of mass be r. So, position vector or radius vector of m1 is r1, m2 is r2, center of mass is r. Now, let us write the moment of m1, moment of m2, moment of center of mass. Moment of a particle about a point is nothing but product of the mass of the particle and perpendicular distance of the particle from the given point. For example, if you want moment of this mass about the origin, then it would be equal to m1 r1. If you want moment of m2 with respect to origin, it would be equal to m2 r2. If you want moment of center of mass about this, mass of center of mass into r. So, moment of m1 is m1 r1, moment of m2 is m2 r2. So, sum of the moments of m1 and m2 are m1 r1 plus m2 r2. Moment of center of mass will be equal to m1 plus m2 into r, where r is the position vector of center of mass. So, moment of center of mass about origin is m1 plus m2 into RCM, because center of mass is the point where total mass appears to be concentrated. m1 plus m2 is the total mass. This into radius vector of center of mass is the moment of center of mass about origin. Now, because center of mass should represent the total moments of all the particles, this must be equal to the sum of the moments of m1 r1 and m1 and m2. It should represent the moments of m1 r1, moments of m1 and m2. Therefore, we can write m1 plus m2 into r center of mass is equal to m1 r1 plus m2 r2. R center of mass is equal to m1 r1 plus m2 r2 by m1 plus m2. So, this is the position vector or radius vector of center of mass if radius vectors of m1 and m2 are known. Now, we know that RCM is giving you three equations for center of mass: XCM, YCM, ZCM, and R1, R2 also indicates three coordinates of m1 and m2. So, you can write RCM is xi plus yj plus zk, XCM into I plus YCM into j plus ZCM into k. That is how you represent RCM. Similarly, R1 will be equal to x1i plus y1j plus z1k. Similarly, R2 is equal to x2i plus y2j plus z2k. So, this is how we represent R1 and R2. So, from this equation you will get three equations for x, y and z. If you write the corresponding values, XCM will become m1 x1 plus m2 x2 by m1 plus m2. Similarly, YCM will become m1 y1 plus m2 y2 by m1 plus m2 and so on. That is why we can get the values of XCM, YCM, ZCM in this method also. This is another way of deriving the relation for x, y, z coordinates of center of mass. Now, so far we know how to find center of mass for discrete objects. Discrete means objects that are having separate identities, separated from one another with different coordinates like that, m1, m2, m3. So, like this, there are so many number of particles This is called a discrete mass distribution, separate mass distribution. For them, we can find center of mass very easily now because we know the relations. What is X center of mass, what is Y center of mass, what is Z center of mass. Now let us do an example relating to this. There are three particles. There are three particles of masses. M1 is equal to 10 grams, M2 is equal to 20 grams, M3 is equal to 30 grams. There are three particles of masses. M1 is equal to 10 grams, M2 is equal to 20 grams, M3 is equal to 30 grams. These three particles have center of mass at 1, 1, 1. The coordinates of center of mass of these three particles are given as 1, 1, 1. Now, where should a fourth particle be placed? Where should a fourth particle be placed so that fourth particle be placed so that the center of mass of a 4 particle system is at 0, 0, 0. See the problem here, there are three particles, their masses are 10 grams, 20 grams, 30 grams, their center of mass have coordinates. See, these three have center of mass here, remember that. The center of mass coordinates of these three particles is given as 1, 1, 1. Now, where should a fourth particle of mass 40 grams, where should a fourth particle of mass 40 grams be placed so that center of mass of 4 particle system is at 0, 0, 0. To do this problem, we apply the knowledge so far we discussed. The formulae which we already derived can be applied to solve this problem. There are two ways of solving this problem also. Let us go for the easier way. Here, all these three particles have center of mass here. By definition, using the definition of center of mass here, follow clearly. By definition, center of mass is the point where the total mass appears to be concentrated. Therefore, this 60 grams is supposed to be at this point. The 60 grams mass is supposed to be at this point, and where you should place a fourth particle of mass 40 grams so that the combination will have center of mass at 0, 0, 0. For that, what we should do? Let us take 60 grams as single mass and its coordinate is x coordinate is 1, y coordinate is 1, z coordinate is 1. No? So, let us suppose 60 grams is 1 mass. This 3 let us take as 1 unit as 60 grams and it is placed at this point 1, 1, 1. That means x coordinate of this 60 grams is 1, y coordinate is 1, z coordinate is 1. Now let the x coordinate of 40 grams be x. Let the x coordinate of 40 grams be x. X coordinate of 60 grams is 1. Then the x coordinate of the combination of this 60 grams and this 40 grams should be at 0. You should catch this point here. 60 grams is the net mass of these three. Because all of them have center of mass here, we can assume that this 60 grams is at this point. That means x, y, z coordinates of 60 grams are 1, 1, 1. Now 40 grams, we don't know the coordinates of the 40 grams which you have to find here. Let them be x, y, z. Let the coordinates of 40 grams be x, y, z. X coordinate is x for the 40 grams. Now, x coordinate of this mass 60 grams and this 40 grams should be equal to 0 according to the problem. That condition is given in the problem. Therefore, what we can write? we can apply this formula XCM is equal to M1 X1 plus M2 X2 by M1 plus M2. Simply we can apply this relation. In place of M1 you can take 60 grams, in place of M2 you can take 40 grams. Then X1 will be equal to 1, X2 will be equal to X. XCM will be 0 because we are given that the resultant coordinate of these two should be equal to 0. Now we can put that equal to 0. M1 is 60, X1 is 1 plus M2 is 40 into X by M1 plus M2 is 100 is equal to 0. So follow this clearly. Here we have taken in place of M1 total mass of these three because their center of mass is given here. We are assuming all the three equal to one particle only of mass 60 grams. 40 grams is placed at the coordinates x, y, z which we have to find. That's why we have taken 40 grams as the second mass and its x coordinate is x. So 60 into 1 plus 40 into x by 100 equal to 0. Therefore 60 plus 40x is equal to 0. Or x is equal to minus 60 by 40, that is minus 3 by 2. So this is the coordinate of x coordinate of the fourth particle which is 40 grams. Now similarly you can find y coordinate also because y coordinate of 60 grams is also 1. Then what we will get 60 into y means 1, 60 into 1 plus 40 into y by 100 equal to 0. 60 into 1 plus 40 by 100 equal to 0. So the same thing will be repeated. 60 plus 40y equal to 0. So y equal to minus 60 by 40. You will get minus 3 by 2 only. So all the coordinates of 40 grams are minus 3 by 2, minus 3 by 2, minus 3 by 2. That means 40 grams should be placed at this point so that the total center of mass of these particles along with 40 grams should be shifted to 0, 0, 0. So this is the example for the formula we discussed.